Hello and welcome guys. In this video we will be implementing deterministic and stochastic policy, or you can say probabilistic policy, and by plotting we will see how both of them are different, how they basically works with the help of grid wall example. So let's get started. Okay, so first of all, obviously what we will do, we will import all the libraries. For this case, obviously numpy and matplotlib will be enough. Okay, now we have to define our gradewall class. Now we will define the step function. Okay, so def step, uh, which will take self and action. So there will be four actions. One will be 0 if it want to move right, action equal to 1 if want to move up, action is 2 if want to move left, else it will be move down if the action is 4. Okay, okay, so let's implement one by one. Okay, let's copy this line of code and paste it everywhere. Now we just have to change the positions. Okay, current state will be 0 only, but it should be, max. Okay, and this part will be no more. And now this will be max -1 comma 0. This is correct only. The last one will be min. Okay, and should be +1. comma self. Now we have to check whether you know all the current step is matching with the goal state or not. Okay, so for that, okay, so let's understand what basically happening here. Okay, so basically in this part we are defining gradable class that represent the environment where the agent is going to learn. And this the environment is 2D grid with a start state and a goal state. The agent has to learn to navigate the grid from state to goal state. And then there is a constructor method initialize the size of grid and the set size goal state to the top left and bottom right corner of the grid respectively. And the step method take input uh, as actions like 0 1 2 3, and move the agent in the corresponding direction, right, like right, up, left or down based on the action. If the agent reaches the goal state, it will return the reward 1 and the goal state. Otherwise it will return a reward of 0 with the new state of the agent. The purpose of this class is to simulate the agent interaction with the environment during the learning process. Okay, now let's define the epsilon greedy policy for our stochastic policy. And then we will also define one more policy, that is greedy policy, for our stochastic no for our deterministic policy. Okay, so let's do that. So that will be outside of our class, so let's define them. Epsilon greedy will take q comma epsilon. It is the same function that we have done in the last few videos. Dumb. Of q. Okay, so we are done with epsilon greedy. Let's define greedy policy now for stochastic for deterministic. Okay, it should take q and it should return argmax of that q. So what we are doing here is, in reinforcement learning, this policy, I mean any policy that defines the mapping from state to action, right? So there are several type of policies available in reinforcement learning, like greedy policy, epsilon greedy, softmax policy, etc. So this policy are used to decide the action to be taken in a given state. So the epsilon greedy policy is popular policy that take the best action with probability 1 minus epsilon and take a random action with probability epsilon. So the purpose of epsilon greedy policy is to balance the exploration and exploitation during the training of RL agent. So the function epsilon greedy policy or you can say this one. So what it does is it defines the implementation of epsilon greedy policy. It takes the state action value function, that is q, and epsilon as the input, and return the action to be taken in the given state. Now the another function, that is greedy, it is defined to implement the greedy policy. It take the state action vector function, action value function, that is q, as input, and return the action with the maximum value. So this policy is used when the agent has to exploit the already learned knowledge to take the best possible action. Okay, so now we will be iterating through all the epsilons we have, and we will be implementing our deterministic and stochastic policy. So let's do that. Okay, and before that we have to set some variable, and those are size equal to 4, number of steps equal to 100, number of trials we want to perform equal to 100, then epsilon's values. Now we have to define our stochastic and deterministic policy reward. For stochastic, will be length of epsilons, comma, and step. And just copy it. This will be deterministic. Okay, so we are good to go. Now let's iterate through all the epsilons we have. Okay, enumerate. We have to iterate till whatever the number of trials we have. Okay, now grid world equal to, we'll call the class world, and we have to pass the size, which is 4, and in q be zeros, size comma 4, we'll take the epsilon greedy action, which is this one, which will come from grid world by passing the current state and the epsilon. And what we will get reward and next step. Okay, in the next line, using the step function. Okay, now we have to append our total rewards. current state and its action. Now we'll append the reward. Okay, and it will be I number of trials. Okay, same way we have to do for uh, deterministic. So let's copy this whole part and paste it here, and I will explain you what basically happening here. But let's first change the required necessary lines. Okay, so there here will be no change, it will be same as it is. Okay, here it will be uh, I mean the next policy, that is greedy policy. Okay, now the next thing we will be changing here is the reward name. The name of the variable will be this, and yeah, we have everything same. Yeah, that's all we have to change. Now let's move to the plotting part, where we will be plotting all the epsilons and their rewards and how they are basically looking. Okay, and before that let me explain you what this code is doing. So basically the code, this you see here, is performing the exploitation analysis on grid world environment by running the trials for both epsilon greedy policy and the greedy policy. So what it basically doing is, so this one is outermost loop. Okay, so it is iterating over the values of epsilon to be used for epsilon greedy policy and the greedy policy. Then there is another loop which is number of trials for each epsilon value to average the result over different random seed. Okay, and for each trial there is a new gridline environment is created and initialized, and the q value table is initialized with zeros for each state and the action. Okay, so this one is the q table, and then a variable, that is you see the total reward, is initialized to 0, which will keep track of total reward obtained over number of step taken. Another array is rewards. It is created to store the cumulative reward obtained at each step of the episode. Okay, so next is here. So we are iterating through number of step. So in each step what we are doing it is it choosing an action according to the current policy in the first loop, and the epsilon greedy policy is used in the second loop, and the greedy policy is used. Okay, after choosing the action, the agent take the step in the environment using the chosen action, and then receive a reward for the next state. Now the total reward is updated by adding the reward obtained at the current step, and then the cumulative reward array is also updated to form a new total reward. And and same thing is happening for this particular uh, uh, using greedy policy, which is for deterministic policy. Now we'll see the plotting part. Okay, so first of all we need to define axis, because there will be two plots because we have two policies. Okay, so figure comma axis, one row two column, and fixed size and then for I in I comma epsilon Wait, silence. So first will be stochastic policy rewards. Of I, comma, the label, copy it again, paste it, just change the access number and the policy. Okay, and rest will be same. Now the only thing is remaining is the legend part, so let's do that as well. Okay, now let's copy the same thing, paste it again, change the axis, and this will be deterministic. Okay, and let's plot it. Okay, okay, we have a error in the line 64, which is saying, okay, we have passed two inputs but it should only take one. Okay, which is correct. Obviously in greedy we have only one input, so let's remove this. Okay, so now we have the plot. Now you can see that, I mean, in deterministic policy, so basically we can see that performance of two different policies, the stochastic and deterministic, as a function of different value of epsilon. The x-axis represent different value of epsilon and the y-axis represent average reward obtained by each policy. And the plot shows that for a stochastic policy, as the value of epsilon increases, the average reward also increases exponentially. This is because a higher value of epsilon implies that the agent is more likely to explore the environment and try out different actions, and this exploration can lead to discovering a better strategy for maximizing reward. On the other hand, we have deterministic policy. The average reward obtained is low, or you can say zero, and remain constant for all the value of epsilon. This is because the deterministic policy always chooses the same action in a given state, which can lead to suboptimal solution. So therefore the plot suggests that the stochastic policy is best suited for situation where the policy is a policy sorry the environment is complex and uncertain, and the exploration is necessary to find optimal solution. The deterministic policy, on the other hand, may be suited for situation where environment is well understood and the optimal strategy is already known. So example would be like, for deterministic, uh, in a game like chess or tic-tac-toe, the optimal move can be determined with certainly I mean based on current state of the board. uh, for stochastic, the game like poker, the optimal move may depend on the action of other player, which are unknown and random. In such cases, and the stochastic policy can help to explore different options and find the best strategy. So hope you guys understand what is the difference between stochastic and deterministic policy. And from next tutorial we will be jumping to some mathematics of reinforcement learning. So suppose like Bellman equation and all that. Okay, so hope you guys have liked this video. Okay, thank you, bye bye.